Half-open and half-closed intervals. Welcome, everyone. Before we dive into today's new topic, let's take a moment to reflect on what we have already covered. In our previous lessons, we explored two specific types of intervals: open intervals, where the endpoints are excluded, and closed intervals, where both endpoints are included in the set. However, as we move into more complex mathematical problems and real-world applications, you will find that life isn't always all or nothing. We often encounter situations where we need to include one specific endpoint while simultaneously excluding the other. To handle these specific cases, we use a special category known as half-open or half-closed intervals. In the next few slides, I will show you exactly how to identify and write these using the correct notation. Understanding half-open, half-closed intervals. Now that we've recalled our previous lessons on open and closed intervals, let's dive into the core definition of what we're studying today. A half-open, or sometimes called a half-closed, interval is simply a subset of the real numbers, which we denote as R, that contains exactly one of its endpoints, but leaves the other one out. To read these intervals correctly, you just need to look at the type of bracket used, as this tells you whether an endpoint is included in the set or not. If you see a square bracket, either on the left or the right, it indicates that the endpoint is included, which we call a closed endpoint. On the other hand, if you see a parenthesis, either on the left or the right, it indicates that the endpoint is excluded, which we call an open endpoint. In the next few slides, we are going to look at the two specific ways we can combine these brackets to form different types of intervals. Types of half-open intervals. Now that we understand the basic difference between square brackets and parentheses, let's look at our first specific type of half-interval. First, we have what we call a left-closed, right-open interval. As the name suggests, this interval is closed on the left side, meaning it includes the starting point, which we'll call A. However, it is open on the right side, meaning it excludes the ending point, which we'll call B. In terms of notation, we write this as an opening square bracket, followed by then a comma, then B, and finally a closing parenthesis. If we were to write this using set builder notation, it would look like this: an opening curly brace, X, followed by a colon, then it is less than or equal to X, which is strictly less than B, and finally a closing curly brace. To put this into plain English, this set consists of every single real number X, provided that X is greater than or equal to our starting value A, but is strictly less than our ending value B. So, while A is part of our set, B is not. In our next slide, we will look at the exact opposite scenario. Types of half-open intervals, continued. Now that we have mastered the left-closed, right-open interval, let's look at the opposite case, which we call a left-open, right-closed interval. In this specific type of interval, we do the exact opposite of what we just saw. We exclude the starting point, but we include the ending point, B. If you look at the notation on the slide, you'll see an open parenthesis at the start and a square bracket at the end, written as open parenthesis, a comma, B, close square bracket. To express this more formally using set builder notation, we write the set of all X such that X is strictly greater than A and X is less than or equal to B. To put this into plain English, the set consists of all real numbers X that are greater than A, but not equal to it, and go up to and include the value of B. As we move to the next slide, I'll show you how this concept actually applies to a real-world scenario, like a store promotion, so you can see these brackets in action. Real-world example, a limited-time offer. Now that we have mastered the formal notation and the difference between left-closed and left-open intervals, let's step away from the abstract symbols for a moment and see how this actually applies to a real-life situation. To understand how these intervals work in practice, consider a promotional sale at a store. Imagine this scenario. A store announces an early bird discount that is valid starting exactly at 9:00 a.m. and lasts until 12:00 p.m., but there is a catch. the discount expires the very moment the clock hits 12:00 p.m. As we move to the next slide, we are going to break this down step by step to see which brackets we should use to represent this time window. Real-world example continued. Now that we have the scenario of the early bird discount in mind, let's walk through a step-by-step breakdown to see how we translate that real-world situation into mathematical notation. First, let's identify our start time. The problem states the discount begins exactly at 9:00 a.m. Because the discount is active at that very moment, 9:00 a.m. is included in our set. In interval notation, whenever an endpoint is included, we use a square bracket. So we start our notation with an opening square bracket, followed by the number 9, and then a comma like this. Open square bracket 9, comma. Next, we look at the end time. The sale lasts until 12:00 p.m., but the moment the clock hits 12, the discount expires. This means 12:00 p.m. is excluded from our interval. To show exclusion, we use a parenthesis, so we follow our comma with the number 12 and a closing parenthesis. By combining these two steps, we can formulate our final interval. The time window for this discount is represented as open square bracket 9, comma, close parenthesis, 12, close parenthesis. Finally, let's look at the formal mathematical interpretation. If we let the variable t represent the time in hours, we can write this using set builder notation. We are looking for the set of all t, such that t is greater than or equal to 9, and t is strictly less than 12. This is written as the set of all t such that t is less than or equal to 9, and t is less than 12. As we move to the next slide, we will compare these two different types of half-intervals side by side to help you keep them straight. Comparison summary. Now that we have looked at both types of intervals individually, let us bring them together. To ensure clarity and help you distinguish between them, let us compare the two types of half-intervals side by side in this summary table. First, let's look at the symbol rho. For a left-closed, right-open interval, we use an opening square bracket followed by a closing parenthesis, written as a open bracket, b, close parenthesis. Conversely, for a left-open, right-closed interval, we use an opening parenthesis and a closing square bracket, written as a open parenthesis, b, close bracket. Next, let's examine the inequality row, which is where most of your calculations will happen. For the first type, the inequality is less than or equal to x, which is strictly less than b. Notice that the equal to part matches our square bracket. For the second type, the inequality is strictly greater than x, which is less than or equal to b again. The equal to part matches our square bracket. To make it even simpler, let's look at the endpoints. For the left-closed version, the left endpoint is included, but the right endpoint b is excluded. For the left-open version, it is the exact opposite. The left endpoint is excluded, while the right endpoint b is included. Keep this comparison in mind as we move on to the next slide, where I will highlight some common pitfalls to watch out for during your exams. Common mistakes to avoid. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. As we've seen throughout this session, the notation for intervals is very precise, and even a small slip-up can change the entire meaning of your set. Here are 3 specific errors I often see students make. First, be very careful not to confuse your brackets with your parentheses. It is a very common mistake to write an open interval, like a parenthesis b parenthesis, when you actually intended to include one of those endpoints. To keep yourself on track, always remember this simple rule. Square brackets, like a square bracket b square bracket, mean the endpoint is inclusive, whereas parentheses, like a parenthesis b parenthesis, mean the endpoint is exclusive. Second, watch your inequality signs. When you are writing out the set builder notation, beginners sometimes accidentally write a is less than x is less than b for a half-open interval. This is incorrect because it fails to show that one side is included. You must ensure that every square bracket has a corresponding or equal to sign. For example, if you have a left-closed interval, your notation should use a is less than or equal to x, is less than b, the symbol and the bracket must always match. Finally, never mix up the order of your numbers. In any interval, you must always write the smaller number, A, first, followed by the larger number. B, writing something like 5 square bracket 2 parenthesis is mathematically undefined and simply doesn't make sense in the context of a number line. Keep these tips in mind, and you'll find that mastering these intervals becomes much more straightforward. Let's move on to our final summary of the key takeaways. Key takeaways. First, remember that half-open or half-closed intervals are specific subsets of the real numbers that include exactly one of their endpoints, leaving the other one out. Next, let's look at the two notations we've practiced. The notation left square bracket, a comma, right parenthesis, b, right parenthesis, represents the set of all x, such that x is greater than or equal to a and strictly less than b. On the other hand, the notation left parenthesis, a comma, b, right parenthesis, right square bracket, represents the set of all x, such that x is strictly greater than a and less than or equal to b. Finally, the most important rule to keep in your toolkit. Always remember that a square bracket indicates inclusion, which corresponds to the less than or equal to or greater than or equal to signs. Conversely, a parenthesis indicates exclusion, which corresponds to the strictly less than or strictly greater than signs. All right, we have reached the end of our lesson. Let's quickly recap the key takeaways to make sure everything is clear before we wrap up. If you can master this distinction, you'll avoid the most common mistakes we discussed earlier. Great job today.